Hey everybody, what's going on? This is a short video about angles, and we're going to introduce angles. So first of all, let's think about what an angle is. So I'm going to start with one segment or ray, and then I'm going to add on to that another segment or ray. And what we essentially have is an angle here, and of course this area in here is the angle itself. Here's the common endpoint for both segments or rays, which we call the vertex. So this guy right here is called a vertex. And here are the two sides, which are segments or rays. Those guys are the sides. Okay. So let's give this some numbers, letters A, B, and C. There are a couple of ways we can name this angle. Since there's only one angle at the vertex, we can call it angle B. Right? Nothing wrong with that. So I can call it angle B, or I can refer to it as angle ABC. Right, A to B to C. Note that B at the vertex is in the middle, or it's the same angle as angles CBA. Okay, C. Oops. I'm going to call that C right here. To B, the vertex, to A. Okay, so anyway, what we want to really think about is what the angle really is, and it's the space in between those two rays or segments with a common endpoint. So we measure that magnitude, and you can do so on this program. Click, click, click. This is Geometer Sketchpad, and that angle is 78.32 degrees, right? So it's acute. It's less than 90. Now it's 108 degrees. It's obtuse, more than 90. If I get it at 90, it's a right angle. Let's see if I can do somewhere around there is a right angle. And if I can get it at 180, exactly, oh no, it would be a straight angle. Okay, I'll just pretend that's 180. All right. So there are different types of angles as well. Okay. What we can do is we can create what's called an internal segment, interior segment, and I'll call that D. That point up here, and this guy right here is an interior internal because it's inside the angle ABC. Now what I've done is I've created two what are called adjacent angles. So adjacent, just like the word in real life, means next to, right? So this angle right here, HBD or DBA, is adjacent to angle DBC. Right, so this angle is adjacent to this angle. In fact, I'm going to put some numbers in there so it's a little bit easier. That's 1 and that's 2. So an example of adjacent angles would be angles 1 and 2, right? Are adjacent. They're next to each other. They share a common ray. They share a side. Okay, angles 1 and 2 will share this segment side ray DB. Okay, so those are adjacent angles. When we have two adjacent angles, actually let's start a new sketch. Scratch that. Bada boom, bada boom. So I'm going to create an angle here. Any old angle. I'll give it some letters. It looks like we're going EFG. How about that? And one thing we can do at an angle, just like we can do to a segment, is bisect it. And so, what do you think it would mean to bisect the angle? Well, let's do it. So I'm going to click, 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 and I'm going to construct this angle bisector. And now that's a little bit too long, so I'm going to put a point on it. I'm going to hide it, the line. So just a little shiftiness here. I'm going to hide that guy, and then I'm going to create my own little bisector here. Bam, bam. And so this guy is an angle bisector. And what angle bisectors do, well, what do you think they do? If a segment bisector is a line ray or segment that hits the midpoint of another segment, then an angle bisector will do what, do you think, to the big angle? That's correct. It's going to create two congruent adjacent angles. But you didn't think I was listening. So an angle bisector, in this case it's FH, is going to create from the larger angles 2, 1, two congruent adjacent angles. So I'm going to call that angle 1, I'll call that angle 2. So an angle bisector, let me see if I can write that out, is going to cut a larger angle into two adjacent angles that are of equal measure. And we'll talk about equal measure means congruent later. So let's just make sure that's happening. So if there's angle 1 here, and here's angle 2. And let's see what happens with this angle bisector segment FH. So we're going to measure the angle 1, boom, boom, boom. And that's 52 and change degrees. It's an acute angle. We're going to measure angle HFG. And that's going to be, what do you know? Hey, they're both the same, right? And so that's what angle bisectors do. They create two equal adjacent angles from the larger angle. So that HF, ray FH or segment HF, bisects angle AEFG, since angle 1 and angle 2 have equal measures. They're adjacent angles. All right. Finally, I have one final idea to present to you, and it's much like segment addition postulate, but it's with angles. And if segment addition postulate works with adding pieces of a segment to get the whole, then angle addition postulate is going to work in the same way, just with angles. Remember, a postulate is obvious, right? So just to introduce, let's say that this angle here were 38.9 degrees. And let's say this angle right here were, that was 80 degrees. Then what would you conclude? You would probably conclude that the whole angle is 39 plus 80, which is 119, right? And that's correct, right? Piece plus piece is going to be the whole 119. And that's what angle addition postulate says. So let's get rid of these numbers and be a little bit more general. So I'm going to call that angle 1. I'm going to call that angle 2. Actually, I'm not going to call it angle 1 and 2. Yes, I am. And I'm just going to label these pieces. I, J, and K. Okay, so as long as we have two adjacent angles, then by the angle addition postulate, piece plus piece equals the whole. And of course, the pieces and the wholes are angles. Each piece are the two adjacent angles, angle 1 and angle 2. In other words, angle 1, really the measure of angle 1, plus the measure of angle 2 is equal to the whole. And the whole angle is angle IJK. We don't want to call that whole angle J because there are 1, 2, 3 angles that share the vertex J. Okay? So this is a little angle addition postulate, and it works in the same way that segment addition postulate does, but just with angles. That'll do it for today. You guys have a great night. See you tomorrow.